of our demonstration of the kind of reactions we'll be speaking of in this project. That was potassium chlorate. We melted it to a molten state and then dropped a gummy bear in. And what's happening here is the sugar inside of the gummy bear is reacting with potassium chlorate. The steam coming out is the water vapor, and the black residue forming around the insides of the test tube is the carbon from the sugar.
The topic for our project is actually oxidation reactions or redox reactions. When crafting our hypothesis, we actually got the idea of modifying temperature, corrosiveness, pressure, and humidity. The question actually arose because of my personal experiences of welding. So this is like just on a daily basis kind of stuff I deal with. We did use potassium chlorate, and that's, like he said, that's what actually reacted with the sugar from the gummy bears.
Double of gummy bears?
So the inspiration for this project had to do with his experience with welding, and we wanted to know how different environments would affect this kind of workplace with these kind of reactions happening on a daily basis. You know, if it could potentially become dangerous under certain circumstances. We watched a video over the help of the explanation of Redox Reactions, and the video was about Fritz Haber. He tried to make nitrogen bombs, but in the process created a fertilizer using nitrogen, which our bodies need to survive, and it helps get that nitrogen into the food that we get inside. We can't take it in naturally. And we did find some similar experiments about the similar topics. One was about hydrogen combustion and how it's affected by humidity. And there was another one that had to do with the redox reaction and temperature and pressure.
If you wish to perform this experiment yourself, I'm going to go ahead and read off the procedures and materials for you. If you want to, you'll need potassium chlorate, a gummy bear, a pilot test tube, a test tube with a stand, gas, a Bunsen burner, fume shield because the reaction lets off chlorine, which is a poisonous gas, gloves and safety glasses. You'll also want to stray from standing in front of the tube just in case it explodes out the front. To create the environment that we wanted our experiment to be subjected to, we decided to alter humidity, temperature, pressure, and corrosiveness of the set environment. To create a humid environment, we suggest using a spray bottle. Put it on this foam and spray it into the tube and around the tube to affect the relative humidity of the area. If you wish to manipulate the temperature of the environment, we suggest leaving the Bunsen burner on until it's 15 degrees Celsius past what the original target temperature was. If you want to affect the air pressure around it, put a bell jar around it and use an air vacuum pump to take some of the air pressure and lower it. And if you want to simulate a corrosive environment, we also suggest that you put 5 milliliters of hydrochloric acid in with the solution. I'd like to pass this on over to Jacob, and he will talk about the lubricant application.
Alright, so for our predictions for the corrosive environment, and then humidity, and then vacuum, and then temperature. For the humidity, if we increase the humidity, the expansiveness would actually decrease because the extra chemicals would actually lessen the reaction. If we increase the humidity for the temperature, it actually would decrease because the humidity is water, and water actually puts out fires, so decrease the temperature. For the loudness, it would be ineffective towards it because water wouldn't muffle it or anything. And then light would not change. For the pressure, which is this one, if we increase the pressure, it would actually push down the solution that's given off, and it would make it to a smaller form, so the expansiveness would decrease. For the temperature of the product, it would actually remain the same because pressure doesn't have really much to do with the temperature. And then for the loudness, it would increase it because the pressure given off will actually allow it to expand a lot faster and a lot harder. And then the light, it also would not affect. For the temperature, which is the thermometer, the expansiveness would increase. Particles would be getting faster and faster, which allowing it to go farther out. For the temperature, increase because, like you said, if you're going 15 degrees Celsius past, then it's going to allow it to increase the temperature. For the loudness, it would be the max decibel for our decibel sound meter. This is what we found on the internet. And the light would be so little already that it wouldn't affect it. For the corrosive environment, it's 1 MHCO. And this would actually lessen all 4 of these stages because the corrosiveness would actually pretty much like kind of eat away at the reaction. I passed around the rubric. It's just showing you what we would use for our experiment and how we would grade it. So in conclusion, I would like to thank you guys for coming again. We did use potassium chlorate for our solution for the gummy bear experiment, and the reason why, like, this ain't going to be as big as the explosiveness as we want, but the most explosiveness they can get when they're coming to elements is the alkyl dose, and that's just common knowledge from chemistry. That's all I have. Do you guys have any questions that you guys would like to ask?
I missed the very beginning of your presentation.